Alright, welcome folks. This is a little video reminding us how we're going to be plotting data and a model function together, and to touch on some of the difficulties you guys might have run into. I apologize for the noise. There's actually a 3D printer running in the background that'll be running for the next 7 hours, so I figured I'd make this video now rather than leaving you guys waiting. So you can actually look at my worksheet and see that I've input already run distances and run times. So I actually went through my Garmin Connect and looked at, for the last 10 runs or so that I've done, the distance in miles that I ran rounded to the nearest hundredth, and the amount of time that it took me for each of those runs. So I took the whatever 40 some seconds, converted that into a decimal. So let's say I wanted to create a model predicting how long it's going to take me to run a particular distance. So for this, we actually probably want to start by looking at what my, in this case, my independent variable is going to be distance, since I'd like to predict based on the distance I'm running what my time will be, and my dependent variable will be run times, and we want to plot this as points. So this is our command for Scatterplot. So you guys have already learned how you can right-click on this to change the title, to change the axes labels. There's also a command you can use built in called labels, where we can just put in quotation marks whatever name we would like. So in this case, my distances in miles, actually distance in miles, will be my independent x variable, and my times in minutes will be my dependent variable. And you can rescale your graph to look a little nicer by pulling on the right-hand corner, and you'll notice it'll snap to be a little more well-distributed. And I can give this graph a title, Dr. Wielden's run times by distance. You'll see when we find a linear function fitting this, I am not a fast runner. This isn't a braggy plot. But let's also, now that we've seen this plot, let's actually give this plot a name and call this my run data plot. If you guys ever run something like this after giving it a new label, you guys might notice the plot, if I hadn't selected that, the plot will actually disappear, and they'll put this just plot command. This is totally fine. This is exactly what it's supposed to do. And this is just letting you know that it saved that variable to the variable run data plot, which you can see now showing up in my variables list on the left. That's now saved and ready to go. I can hide that output with a colon, and I can reprint the graph using a little percent symbol. So you can actually get around some of these hidden things using colons to suppress output that you don't like or that make it look ugly. And what this percent symbol does is it prints whatever the last command you ran was, or what the output that it saved is. So I've now saved my actual data by distance. And you can see a cluster right around 3.12 of various times. That's apparently I run more 5Ks than anything else. And now that we've got that data in, we can actually figure out let's pick two of my data points. Let's say looking at, I think probably my first and my last in terms of order. So whatever I have, my 1.8, which is paired up with 20.6. So that's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th data point. So if I want to make a model function, I'm going to make my slope go from my times, or my dependent variable, so my 11th data point, minus my 6 point something run. So that's my 12th data point. You'll actually notice I can't just pick, because they're in that order, I can't pick starting at the first and moving up to the last. I have to look where in my list those two values are, and they're respectively 11 and 12. And divide by run distances. So since I made distance my distances minus run distances 12. So my slope, which we can actually interpret here as apparently on average I take about 11.5 minutes per mile, so not a fast runner. We can actually put this all in the same box to run. You have to put a semicolon at the end of a line, but you can hit Shift-Enter to go to another line inside the same box if you'd like. So my y-intercept for this, since we know our formula for a line is going to be y minus mx plus b, we can solve for our slope. So since we know that like y equals mx plus b, our y's are our run times, so let's maybe have it pass through the 11th data point, and our x's are run distances. Note that I used the same point, so the distances and the times, not one from each. And so that says I apparently travel 0 miles in -5 seconds. So my y-intercept isn't particularly physically meaningful in this case. But we'll make up my model function. Let's just call it f, which will take in my distance I'd like to travel, and I'll output mx plus b. I'm going to create a new plot, which I'm going to call model plot. To plot this model function, my shortest time is 1.81, so I'm going to plot from around x equals 1.5 up to the longest distance that I've run in this graph is apparently 6.2, so maybe up to 6.5. And I'm going to make the color of this graph blue. And remember, I don't really want to look at, if I save this as a variable, again, it'll just output this plot. I can use a semicolon to hide that, and actually look at my graph. Not particularly exciting here, but I could use that % sign to have it appear. What many of you guys might have noticed when you were trying to run your worksheets later is if you use this display command that we encourage you to use, and note that my variable names are run data plot and model plot. Maybe I should, just for consistency, call this run model plot, and I'm going to get rid of my model plot variable by right-clicking on this and unassigning it. So my run model plot and my run data plot, you guys might have seen something like this. So what this means is the display command isn't something that's built into Maple without specifically being loaded. So before we run display, we'd have to run the command with plots. And if you look, we've done this a couple times in class, but just to remind you in this video, you'll actually see the command display is something that's loaded by this with plots package. So when you save a worksheet, close it and reopen it the next time, you've actually lost all of your variables and you've lost your display command. So you need to rerun this with plots, and we actually have always traditionally in worksheets hidden this with a colon because this is a lot of stuff to look at. So we're going to hide it, and now when I run display, there's my graph nicely labeled. And you'll actually notice I lost my axes label, so it's just listed as X. If ever you see something like that, the two ways to get around it are you can add axes labels to both of your saved plots, or you can change the order that you put these plots into the display command. So our run data plot and our run model plot, changing the order, we see that it's only the first one that will save our, whichever one is first, if we had a saved set of axes labels, which we used this command labels to get last time, that'll appear. So again, the most common errors that students run into are forgetting this with plots. So this is a very important thing to keep in your worksheet. So remember to load that with plots, and forgetting to rerun through the variables that they were using in a previous instance of this worksheet. So anytime you're planning on using something, it depends on, let's say, the data being available in these two lists, or having our parameters that we saved for our model function available. Make sure you look in your variables list, which if this was in a different order, it might be hidden from you guys. You can just hunt through this left-hand side until you find your list of variables and see which ones have already been run. That's it for this video, and I'll see you guys in class tomorrow.